Well, if you work in manufacturing, quality or operations, sooner or later you'll deal with quality complaints. First thing that you might do is start taking a look at records. You'll do your investigation by looking at the data, looking at the reports, looking at the quality tech audits. Try to find out what went on. You'll go and talk to operators and supervisors. Maybe you'll be fortunate enough to have retained samples that you've produced and put in storage. Likely you'll get some products back, or you'll have to go out to the field, submit those samples to the laboratory, and you'll start making your report of corrective action. But unfortunately, there never is really enough information to understand the real root cause and understand what those process variables were doing to you at that particular point in time. So this presentation is a focus on the process, not so much the product, to understand process variables better so that we can control and predict the production of the product so it meets specifications all the time. So this is one of our elements of our practical problem solving toolkit, a focus on the process. So I'm Mike Vella. I'm recently retired, 42 years in operations and quality. Spent 30 years at an automotive OEM supplier of safety critical parts, and the last 12 years of my career in food manufacturing. My undergraduate degrees in aviation engineering and technology from Western Michigan University and MBA in finance from Wayne State. Proud to be a senior and fellow member of the American Society for Quality. I'm a certified quality engineer and certified reliability engineer. Since this presentation is about focus on the process, how about some definitions? Process. It's a series of actions, steps, motions, or operations leading to some result in the manufacturing process. It's also a unique combination of machine tools, methods, materials, and people engaged in production. At this point in time, we're not talking about administrative processes, we're talking about manufacturing processes. Some more definitions. Process control and process capability. So process control is the method of defining and monitoring those key process inputs which accurately predict process performance. And process capability is the ability of those process controls to operate the process, providing a continual adherence to requirements. Well, let's use the analogy of an aircraft pilot. Pilot really knows very well how each one of those switches and gauges that he has in front of him affect the attitude of the airplane, speed, direction, altitude. So consider that analogy with your particular production process. If you don't know which are the key process inputs, if you don't know how they operate, if you don't know their current status, then how can you predict process control? So again, when you think about process focus, consider a production part made up of three components: raw material 1, raw material 2, and those feed into process inputs. If those process inputs are in control, then it's very likely that the product output will be in control. On the other hand, if one of those process inputs is out of control, it's impossible to consider that the product output will be in control. Out of control process inputs will always result in out of control product outputs. Well, the truth is, if you can't define it, you can't measure it. If you can't measure it, you won't be able to improve it. And if you can't improve it, someone else will. So let's consider plant management. Plant managers have a process too. Their objective is to maximize profit and cash in their factory and have a business that runs so well that it grows. Now, how do they do that? They certainly have certain controls. They want to have a control on inventory, on-time delivery, quality, absenteeism, safety, turnover, scrap, yield, productivity, launch, and more. And if they have some kind of system where they measure and report on that, they hope to get profit and cash. But is that enough? I don't think so. Simply measuring and reporting it, all those things, is not a sustainable process. You've got to have some controls over those process elements. You've got to understand the controls so that those things can be repeatable. That is a sustainable model. Let me continue. So let's just take one element of those plant managers' inputs for profit, cash, and growth. Inventory, very important. So how does a plant manager make sure that their inventory is in control? Certainly not just by measuring and reporting. They've got to have some kind of method to control inventory. One might be adherence to planned consumption. You're supposed to use 3 screws for the assembly. You can't use 4, because if you use 4 over thousands or perhaps millions of units, you're going to have a shortage. Every once in a while, you're going to have an inventory. Maybe it's weekly, maybe it's monthly, maybe it's annual. You have to have accurate counts so that you can reconcile the inventory. You've got to be able to order on time. Materials can't come in late, can't run out. And when it does come in, you got to make sure that whatever comes off the trailer is received properly. If you're ordering 10,000 and you expect to have 10,000 and only 5,000 come in, goes in inventory, it's entered as 10,000, you're going to be 5,000 short. You've got to have good security. You got to make sure that that product doesn't, raw materials don't walk off the floor. And you got to have some method to store the products properly so they don't deteriorate. How about another one? Let's consider safety. Safety, very important. It's a plant manager's, career, manufacturing products so that they can get profit, cash, and growth. So what's the process of safety? Standing up every month and saying safety is important, flags and banners, safety is number one? No. You've got to understand the controls to get good safety. What does that mean? You've got to create maybe a safety culture. Thousands of different steps that you do to create a safety culture. Perhaps it's leadership by example. You don't, as a leader, go on a production floor and operate in an unsafe manner. Don't use your PPE, your personal protective equipment, when you expect other people to do so. You've got to show strong leadership. You've got to have exhaustive safety corrective actions. When there is an accident, you have to look into it carefully, understand the nature of the problem, and correct it. You got to listen for safety suggestions, get feedback from the people involved. You have to have safety audits, go out there and check things out, make sure people are operating in a proper way, using the tools are in good condition, and so forth. Maybe you have outside consultants come in and validate your safety program. Maybe you have routine meetings and communication. It's more than just banners. It's more than just measuring, reporting. That's not sustainable. You have to be able to understand the controls for safety, and therefore the result will be what you want. Now, once you understand all those things and you do them very well, then perhaps those process controls, safety culture, leadership by example, and so forth, maybe then you get very, very good at it. And now we say it's got process capability. So now you have process capability of those process controls, which then leads you to good safety, which then leads you to your goal of profit, cash, and growth. Back to these definitions. Process control is a method of defining and monitoring those key process inputs which accurately predict the process performance. And process capability is the ability of the process controls to operate the process, providing continual adherence to requirements. So the process control is different than a process capability. And what you really want to have is process capability. Let's take another look at this and explain it in another way. Quadrant charts, horizontal, in control, out of control, vertical, in spec, out of spec. Where we all want to be is in quadrant 1, in control, that is repeatable, and in spec, conforming to specification. It's also possible to be out of control and in spec. Pretty dangerous to be out of control and in spec because it could lead you to quadrant 4. Let's take a look at quadrant 3, in control and out of spec. Now, that means you're very, very repeatable, but you're simply not conforming to specification. And of course, in quadrant 4, you're out of control and out of spec. So back to our 4 quadrants. In control, in spec, out of control, in spec. You you analyze control using statistical analysis, like statistical process control. You can tell whether you're in control or out of control using statistical analysis. Capability analysis tells you whether you're in spec or out of spec. Back to the definitions. Process control is a method of defining and monitoring key process inputs that accurately predict process performance, and process capability is that ability for process controls to operate the process, providing continual adherence to requirements. Again, using my airplane analogy, here you go, you got a pilot flying nice and level, everybody's happy. Now you got a mountain. So in one case, you're in control. Are you capable? What you don't want to do is have that airplane run into the mountain. That would be out of spec. Let's get back to production processes. Plastics. Everybody uses plastics around us. Here's examples of plastics, and plastic injection molding is what I want to talk about next. 5 containers there. Milk container, the thing on the top, the cap is plastic injection molded. The milk carton itself is probably blow molded. To the right, a food container, the lid is injection molded. The cup itself is probably injection molded. On the left, another lid and cup, both probably injection molded. Protein milk bottle there. The bottle itself is probably blow molded. The cap is injection molded. And the prescription bottle, both of those are injection molded. Now, the reason I want to talk about injection molding is not that I'm any expert on injection molding, but it's a very interesting process that requires analysis and control of many, many process inputs. Now, if you take a look at this particular video, if you link plastic injection molding into YouTube, you'll get a great education from Bill Hamich, the engineer guy from the University of Illinois, and he'll talk to you about plastic injection molding. And there is an authority about plastic injection molding, and he'll talk to you. So that video, that YouTube video, will talk to you about plastic injection molding. So you have a rough diagram of injection molding there. Up on the left, you have pellets, plastic pellets that are in a hopper. And they oftentimes gravity feed into a screw process, and that screw is rotating. And the pellets go into the screw, and they're being compressed and heated at the same time. By the time they get to the nozzle, the plastic is molten. The screw moves to the right and pushes the plastic into the mold. The mold is then filled with plastic, clamps, it's filled with plastic, it's cooled with water, When the cycle is about ready to be finished, the mold opens and the ejector pins push the part out. And that's how injection molding works. Injection molding uses very precise dies to capture the molds. And here's a picture of a injection molding process. I am absolutely no expert in plastic injection molding, and I invite you to go back to that YouTube process, a movie, to get a much better education. But the point is that there are many, many different process variables, process inputs that you have to be able to master if you're going to be very good at plastic injection molding. I went on the internet and found this particular source for different parameters of process controls for the 17 most common plastics. And you can see there's temperature of the screw barrel, and it has, in this case, 5 different areas. Material melt temperature, constant temperature of the barrel, mold temperature, injection pressure, holding pressure, back pressure, injection speed, screw speed, metering stroke. I have no clue whether this is accurate, but it seems like these process controls are very, very important to making a high quality plastic injection molded part. Point is, how do you control each one of those process variables? So process controls have to fit someplace. So how do you figure out the best approach for cost and quality, and where do we put our efforts? So you find typical quality control looks at the product as soon as it comes out of the process. People decide whether it's good or bad, and they short or ship based on that. They looked at the product. If the product is not right, then they adjust the process. Maybe again, you got those process variables on the left-hand side. It's not the optimum method. You really have to have a process focus. You have to be able to look at the process variables, move the process controls upstream, get capability on those process variables, just like the pilot example. That pilot absolutely knows how to control the attitude, the speed, and direction of that aircraft based on those process inputs. You have to understand each one of those process variables and have great capability of those so that you understand what the product is going to be. Because if you do, you have happy days. Point is, drive to the source. Look towards process control. Get capabilities on those process controls. Understand how they operate. Make sure that you have mastery of those process controls. Because when you do, you'll have profound knowledge and understanding those process variables, understanding what level they are at, what each one does, so that when you get that customer complaint, you can go back and understand, gee whiz, that temperature maybe was too high. That barrel temperature was too low. That speed was too slow. If you have an understanding of which each of those process variables may be in their particular setting, was it optimum, was it high or low, then you'll understand how those affect the process and eventually affect the product. That's profound knowledge. So what do you do next? Determine who is your customer. What is their requirement? You've got to understand what the customer expects from you. You have to have an agreement on gauges and methods of measurement. Oftentimes, you may have to build a gauge for your customer, or your customer may build a gauge for you if they specify things that closely. How do you determine what is a good quality part? Back to the process. Understand what's very, very precise about your material, the tooling, the maintenance of the tooling, the setting of those process variables. Which energy sources are you using? How much energy? and the skills of the people. Determine your ability to control a process. Use statistical process controls. Use automated machine controls. And determine statistical stability. Remember, process control has to do with statistical control. Determine the process capability. Now, can you, if your process is running control, meet the customer's requirements? Because back like in the matrix a few slides ago, it's possible to have a stable process, but still not meet the customer specification. Use that Deming or Shewhart cycle. Plan, do, check, act. That's what this is all about. Plan your process, do it, check it, recheck it, and act. So thank you very much for your attention. If you have any questions associated with this presentation, please contact me at mvimproves@gmail.com.